Okay, Madison. So when we're looking at number 9, we're supposed to solve for x. I believe. Let me make sure. Yep, just find the value of x. So when we look at this problem, we can see that this angle is 60 and that this angle is 60, right? Well, we know the interior angles of a triangle add up to equal what? That's correct. They add up to 180. So if they add up to 180, what's that third angle going to be? Yes, it will also be 60. So if we know all of these angles are equal, that should tell us that all of the opposite sides are equal, right? So we know that 7 is going to be congruent to that side and is congruent to that side. So we can say 7 equals 2x minus 3. And then solve for x. So we'll add 3 to both sides and get 10 equals 2x. And then divide both sides by 2 and get x equals 5. Does that make sense? You're welcome. Yeah, Isabel, give me just a second to pull that screen up. Okay, so for this problem, Isabel, we're supposed to find the perimeter of the triangle. Remember, the perimeter is all of the outsides added together, right? But in this triangle, we don't know what the perimeter equals. So we can't just set them all, like say 2x minus 1 plus x plus 4 plus 7 equals something. We've got to figure out what that x is first. So what we're going to have to do, since we have these angle notations down here, we know that the opposite sides have the same measure, right? So we know that those two sides equal each other. So if we set those equal to each other, now we can solve for x. So if we subtract an x here, we're going to have x minus 1 equals 4. And then add 1, we'll get x equals 5. Okay? So now we can plug back in. 2 times 5 is 10, minus 1 is 9. And then 5 plus 4 is 9. And this side is 7. So the perimeter equals 9 plus 9 plus 7. Which is 25. Does that make sense? You're welcome. So on those problems, you have to figure out what sides you can set equal to each other so you can solve for your variable, then plug back in and then solve for the perimeter. Okay, Madison, so number 14, you're supposed to find the values of x and y. Okay. On this one, we know that we can set, well, okay, first off, we see that these two sides are congruent, right? So that should tell us that these angles can match up. So we could set both of those equal to each other, but that's not going to help give us one of the variables, right? Now, we do know that those two angles would be equal. We also know that the interior angles of a triangle we talked about a while ago add up to 180. So if we do that, we can see what the remaining angles of the triangle would add up to. So 180 minus 98 gives you 82. And since you know these two angles are congruent, then 82 divided by 2 is going to give you what those two angles equal, right? And then do you see where to go from there? Okay, good. You're welcome. Okay, Megan, probably the easiest thing is going to be to show you the picture that the book has drawn. So for number 12, if you see, so the problem says explain why segments connecting any pair of corresponding vertices. So those are going to be points on a pentagon that are across from each other. And it says of congruent pentagons are congruent, and then make a sketch to support your answer. So if you look at, let me see. Okay, so if you look down here at this picture, you've got these pentagons. They are, it tells you, the problem tells you that they're congruent pentagons so that we know this measure is congruent to that measure, this to this measure, etc., right? We also know that the angles will be congruent. So if we draw a diagonal like this to connect corresponding parts, right? Then what it's asking is, why are these segments also congruent? Well, if we look, what we've made is two triangles, which are also congruent because we have side, angle, side, right? Side, angle, side. So that's going to tell us that these sides of the triangle are also congruent because of CP-CTC, because corresponding parts of congruent triangles are congruent. Okay. Did that help make sense of that one? Okay. And then 14 through 22. Okay. So when we look at 14, which set of given information does not allow you to conclude that AD is congruent to CD? So if we look at AE is congruent to CE, we're trying to prove that these are congruent, right? AE is congruent to CE, and the measure of BEA is 90 degrees. So we could tell from that that this angle is 90 degrees and that this angle would be 90 degrees, because these two would form a linear pair as well as those two. And that would give us a side, an angle, and a side. So then we could tell, that gives us enough information to prove that those parts would be congruent. So that one works, okay? Then if we look at BA is congruent. I was muted that whole time, so nobody got any of that, huh? All right, so if you look, let's look at A. AE is congruent to CE.
Miss Smith, someone muted you again.
Oh, I see. That should not be a problem anymore, it looks like. Okay. Thank you for speaking up and telling me again. So let's try this again. When we look at number 14, we're trying to show which set of information does not let you prove that this side is congruent to this side, okay? So when you see AE is congruent to CE, and then the measure of angle BEA is 90 degrees, right? This angle is a linear pair with this angle, so we know this one will also be 90 degrees. And we know these two are linear pairs, so this side's 90 degrees as well. So when we talk about these two triangles here, we know this side, this angle, this side, this angle, and then we also know this side because of the reflexive property. So that proves that these two triangles are congruent, which would give us reason to see that those two sides would be congruent. So A would work, okay? Now if we look at B, it says BA is congruent to BC, and then angle BDC, which is down here, is congruent to BDA. Well, that's these angles and these sides. And they don't have anything to do with the same triangles. There's no relationship between those sides and these angles that we can use. So B is not going to let us prove that those sides are congruent. So that's why the answer to that one would be B. Okay. So let's see. And then 14 through 22. Oh, that was 14. Okay, so 15 through 20. Those are all planning for a proof. So just kind of explaining what you see in there in the diagram and how you're going to set that up as a proof. So we're trying to prove that angle 1 is congruent to angle 2. Okay. Let's see. If we look at 15 here, look at the diagram and see what we have marked, okay? We know that we have two triangles here, this one and then this one, or two big triangles, I guess. And we see that they both have right angles here, and they both have congruent angles there. So they each have two congruent angles. And then when we look at that, we also see that they have congruent side because FG is shared between the two triangles. So angle, angle, side proves that those triangles are congruent. Let's see. Well, I guess angle 1 and 2 are in those smaller triangles, huh? So if we look at that, well, proving that those two big triangles are congruent is the first step. And so then we would be able to say that these sides are congruent of these smaller triangles, okay? So since we can see that these two sides are congruent because corresponding parts of the congruent triangles are congruent, we would know that this angle and this side would be congruent, right? And what we're trying to prove is that 1 and 2 are congruent. We know that these two angles here would be congruent because they're vertical angles. So we would have, again, an angle, and a side. So that would give us enough information to say that the whole triangle is congruent. And then angle 1 and 2 would be CPCTC for that. Yeah, Megan, that number 15 is confusing because it does look like 1 and 2 are labeled as the 90-degree angle. They should have maybe used a different color. I think 1 and 2 are supposed to be those small angles. Like angle 1 would be KFJ, and angle 2 would be HGJ. Does that help make better sense of that one? Okay. And then basically that's what you'll do for 16 through 20 also. You'll just have to kind of look at it and just kind of process, yeah, angle, angle, side, then CP, CTC. You had to prove the two big triangles first, and then the two small triangles, both of them by angle, angle, side. And then CP, CTC lets you show that that angle 1 and 2 are congruent. So it's just kind of following the diagram, looking at it to see what you can tell just by looking at it, and just kind of writing that out. It's less formal than a 2-column proof. And then for 21 and 22, use the vertices of A, B, C, and D, E, F to show that angle A is congruent to angle D, and then explain your reasoning. So for those two, you're going to have to, well, really what I would start out doing when I see points like this and I need to try to say that the triangles are congruent, I would check and try to do the distance formula on those. So if you draw two triangles and think about them, yeah, exactly, Megan. It is the distance formula. So you would do the distance between A and B, B to C, and then A to C, and then D and E, E to F, and then D to F. And then if the sides are congruent, the angles would also be congruent. Okay, Ethan, you wanted, let's see, number 19 on the worksheet. Okay, Ethan, so if you look at number 19, what does the diagram tell us about the triangle? What does the diagram tell us about this triangle? That's not the same problem you have on your worksheet? Oh, 15. Okay. Give me just a second. Okay. Is that better? Okay. So if we look at number 15, we're supposed to find the value of x and the value of y. So when we look at these two, what can we conclude about the angles, about this angle and this angle, since we have these marks here? Yeah, they're congruent. So that means we can set them equal to each other, right? So since we can set those two angles equal to each other, we should be able to solve for x and figure out what x is. And then also, if we take that information, how can we then figure out what y is? We know that all three angles add together to equal 180. So it will be 180 minus 53 minus 53 equals the 8y plus 10, right? Because both of those other angles equal 53. So that would be how you would solve that one, okay? Okay, Madison, number 22 on the worksheet. We're supposed to, let me see what we're solving for. We're supposed to find the perimeter of that triangle, okay? So when we look at that, since we know that all of these angles are congruent, right? what does that tell us about all of the sides? Well, all of the angles do equal 180, but since we know that they're congruent, the sides are also all congruent, okay? So we can say, yeah, so you can set two of those sides equal to each other and find out what x is, then plug back in for all three sides to find the lengths. Or really, you could just do one since they're all congruent to each other and then multiply that number by 3 to get your perimeter. Does that make sense? Okay, so if we said 2x plus 17 equals 7x plus 2, then we need to solve for x, right? So the way that we would do that is subtract 2x. So 7x minus 2x leaves you with 5x. Okay. And then I'm going to subtract 2 from both sides. So you get 15 equals 5x. And then divide both sides by 5. So you get 3 equals x, right? So now you're going to plug 3 back in. Okay. So 7 times 3 plus 2. So that's 21 plus 2. So that's 23. So since we know that all three sides are congruent, we don't really have to plug back in here and here because they're all going to equal 23 anyway. So your perimeter equals 23 plus 23 plus 23. Does that make better sense? Okay, good. So Ethan, number 8 through 13 on the worksheet, you have to look at the triangles and figure out what you can set equal to each other to solve for x. And then Larkin, you asked on the quiz, are we going to have to actually write out the proofs or are we going to have to fill them in? So the quiz is going to have pictures on it. And you're going to have to look at the picture and see how you can show that those two triangles are congruent. By looking at the diagram, would you use angle, side, angle, 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 side, 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 hypotenuse, leg? And then it's going to tell you whichever reason you're using to prove those triangles congruent. It'll say, go to your picture and color number 1 green. So all of the number 1s you'd color green. You're welcome. Hey guys, don't forget to bring something tomorrow to color with. You need your colored pencils or markers or crayons or something like that, okay? So if you don't have them in your backpack, I would go grab them now and put them in there. That could get pretty messy, Ethan. I don't know that I would use. Madison, the sides that are congruent are the ones that are opposite the angles that are congruent. So when you look at that, which side is opposite of one of the congruent angles? Yeah, so you'd use the 28 for that one. Ethan, you wanted to know how I did number 14, right? Let me see if I still have that where I can pull it up. Okay, Ethan, so here's number 14. When you look at this, since we have those two sides marked congruent, what does that tell us about those two angles that are across from them, that are opposite from those sides. Yes, so those two angles are congruent. And then what do we know about the interior angles of a triangle? No, the interior angles of a triangle are not necessarily congruent. They all add up to what? Right, they all add up to 180. So we know that those two bottom angles are equal to each other. The interior angles are all going to add up to 180. So if we subtract that 98 degree angle, that leaves us 82 degrees. And we know that those two are both congruent, so they have the same measure. So if we divide 82 by 2, that tells us what those two angles equal. So each of those two angles equal 41 degrees. So now you can set 5x plus 6 equal to 41 and y minus 9 equal to 41 and solve for both your variables. Does that make sense? Okay, good. Madison, number 16 is going to be similar to number, well, I guess it's not super similar to number 14. Let me pull up an image of it. So if you look at the if you look at the diagram or look at the picture, what do we know about those two angles that are across from the congruent sides? Yep, those are congruent. So you can set those equal to each other and solve for y. And then you can use that to figure out what those two angles, what the measure of those two angles actually is. And then use the fact that we know the interior angles all add up to 180 to figure out what that third angle is supposed to be, and then set that one equal to that measure and solve for x. You're welcome, Madison. Ethan, on 17 through 22, you're supposed to find the perimeter. Remember, the perimeter is adding all of the outside lengths. So what you're going to have to do is see what you can set equal to each other according to the diagram. That way you can solve for your variable. Then plug back in to those equations so that you can see what your side lengths are, and then add all three of them together to get your perimeter. So if you look at number 17, what do we know on that triangle that we can set equal to each other? Yeah, you can set those two long sides equal to each other, right? Because they are opposite those congruent angles. So if you set 2x minus 1 equal to x plus 4, you can solve for x. And then you can use that information to plug back into, plug x into 2x minus 1 and x plus 4 so that you can see what those lengths are. And then you'll add those two plus 7 to get the whole perimeter of that triangle. So Ethan, on number 17, we know that those two sides, the 2x minus 1 side and the x plus 4 side, are the same, right? They're congruent. So you can set those equal to each other. You would say 2x minus 1 equals x plus 4, and then solve for x. Bring your x's to one side, your numbers to the other. I worked out number 17 already on here. So in just a minute, when I post the link, you can go back through the video and find that, okay? If you still need more help on that one. You guys, if you don't have any more questions, any more last minute questions, I'm going to go ahead and sign off in just a minute because I'm going to have to go get my kids off the bus. Anything else? You're welcome, Larkin. You're welcome, Ethan.